Good morning, ladies and gentlemen. Today we're looking at factorising by completing the square. Now, completing the square is an incredibly useful tool that we'll use to manipulate quadratics later on. Factorising by completing the square is a little bit painful, but it's useful in that it almost always works. Okay, it does always work when the quadratic can be factorised. So take a look at the quadratic on the screen now. You'd be thinking, great, it's monic, meaning there's a 1 at the front, we don't have to do anything too fancy. And then you'd be thinking, well, what adds to 5 and multiplies to 11? And you'd be like, well, what are factors of 11? Well, there's 1 and 11 and nothing else. So using sum of product here, you'd be stuck, which is why we need to complete the square. It works all the time, but it's a little bit miserable, especially when the start is not equal to 1, when a is not equal to 1. Alright, there's a couple of useful tools we need to remember here. Remember that x plus a all squared expands out to x squared plus 2ax plus a squared. X take a all squared expands out to that. And remember that this looks like that. We're going to be using a combination of all three of these to help us factorise more difficult quadratics. Alright, take this one here. X squared plus 10x minus 5. Clearly, nothing multiplies to minus 5 and adds to 10, so we've got to try completing the square. Alright. Step 1, ensure there's a leading coefficient of 1. There is. If there's not, you have to force a factor out, and that's not necessarily good. Then halve the b term. This is the b term. Remember, that's our a and our c. Halve the b term. So the b term is 10 over 2. Okay? Halve the b term. And then we're going to square it. And squaring that gets us to 25. 10 on 2 squared is 25. And what we're going to do here is we're going to add that b on 2 squared, that's our 25, add it on and take it off again. So we're going to write this as x squared plus 10x plus 25, take 5, take 25. And we're always going to add it on. And this sounds like a really odd thing to do, but we haven't changed it at all. We've just added a number on and taken the same number off the end. Providing we've done this well, this here works out to be a perfect square. Remember talking about the briefly last video. Which means it will factorise into x plus 5 all squared. And note, this plus 5 is always going to be the same as b on 2, or in our case here, the 10 on 2. Then what remains is take 30. Minus 5 minus 25 is take 30. Alright, so far we've used this here. Perfect square but in reverse. Now, remember something, x squared take a, we can factorise. So some number squared, take a, and any number we can factorise using that square root trick. That's what we have here. We have some number squared, or x plus 5 all squared, take 30. We can think of 30 as root 30 squared. So this factorises as x plus 5 plus root 30, x plus 5 take root 30. A little bit painful, but doable. You just got to remember here, that 30, it can be written as root 30 squared, and therefore what you've got actually looks like a squared take b squared, where your a is x plus 5 and your b is 30. Sorry, your b is root 30. Alright, let's do a couple more examples. Step 1, ensure leading coefficient is 1. No worries. Take out the b term. The b term is minus 8. Halve it, square it. Half of that is minus 4. Squared is positive 16. We're going to add 16 on, take 16 off. So this becomes x squared, take 8x, plus 16, plus 13, take the 16 off again. This here will be a perfect square. And the term used in the perfect square will be this b on 2 term. Note b on 2 is minus 4. So that becomes x take 4 squared. And if you want to check, you can multiply x take 4 squared out, and it should go back up to the one above, those three terms I've highlighted there. Take 3. 13 take 6 is 16 is negative 3. Then we factorise. Remembering 3 can be thought of as root 3 squared. So x take 4 plus root 3, x take 4 take root 3. Alright, next, and I believe, yes, last example. Stay with me. This one looks a little different because there's not a 2 out the, well, there's a 2 minus 2 out the front. We want a 1 out the front. So our first step to any factorisation here is to pull out the minus 2. Then what we've got left is x squared plus 2x minus 5. Now clearly nothing multiplies to minus 5, that adds to positive 2. So we start to complete the square. Take the b term, divide it by 2, square it equals 1. Leave our minus 2 hanging on the outside, and then keep everything on the inside here. X squared plus 2x, add the 1 on, and remember to take it off at the end. Minus 2. This here then becomes a perfect square. X plus 1 all squared minus 6. Keep going, leaving the 2 out there, and factorise that middle bit. Minus 2, x plus 1 plus root 6, x plus 1 take root 6. And that's it factorised. If you're really, up for a challenge, you can multiply that back out and make sure we head back up to where we were beginning with. Alright, I believe we're done for the video. Thank you very much, I'll see you tomorrow.